So let's look at these problems from lesson 83. So here we've got some distribution that has to happen. So let's do that first to simplify. So we have b plus 2 times a, or y to the a power. So that's going to be y ab plus 2a. And then we have this other base y here, minus ab, over, and I like to change these around just because, you know, I'm a lazy mathematician and I don't like to write more signs than I have to. All right, so we know we can break this down given the principle x to the m times x to the n equals xm plus n. That's the same thing we have going on here. So we can actually break this down into two different factors. So that's going to be y ab, y 2a, y minus ab. That also means that we can break down these two factors down here on the bottom. So it'd be y a, y to the negative 2. So now that we have everything broken down, what we can do is we can combine some like terms. So the first thing that I see is that we have y to the positive ab, y to the negative ab. Those are opposites, so they cancel each other out. So we can go ahead and eliminate those. The other thing I see is that I can now move this from the bottom to the top to make life a little bit easier, so everything is in the numerator. So that's going to mean that I have y to the 2a, that's the original one in the numerator, and now when I bring this from the denominator to the numerator, I get y minus a, and when I bring this one up, it's going to change the sign to a positive, y positive 2. So again, using the principle of addition and subtraction here with the same base, 2a minus, we know there's a 1a right there. 2a minus 1a, that's going to be y to the a power. And then I have y to the 2. And using the same principle, we are going to add these back together, and we're going to end up with y is equal to a, I don't know why I said y is equal. That's going to be equal to y a plus 2 to the a plus 2 power. So a plus 2. And if it doesn't take it like that, you can say y 2 plus a. It's going to be one of those. I'm not sure which one it's going to be. But you can just type this one in and then type that one in. To see which one in which format it is. And I might actually have both of them in there, so it might not matter. All right, that is the first problem. Okay, here's another one that we have. So we are going to combine these bases. So what I have here, I have x and I have m. I have x m over 5. I have a 3x, and I have a x over 2. Now, it would be really easy for me to put these together, m plus m over 5, and then a 3x plus x over 2. It'd be a lot easier to express that as a fraction with a common denominator. Let me see how far this problem goes. Okay, so the problem wants you to do that. I want you to put this all into one fractional response. So what we want to do is we want to find a common denominator, and that common denominator here for the x base is 5. So we're going to take this to the side here, m plus m over 5. And we know that we need to give this a common denominator of 5. So we're going to multiply by 5 over 5, put that over 1. So now we have 5m plus m over 5. This can be simplified. These can be added together now. So that's going to equal 6m over 5. That's our new fraction. fractional exponent for x, 6m over 5. We can do the same thing with the base of a. So we're going to take 3x, put it over 1, times x, or not times, sorry, plus x over 2. We need to have a common denominator of 2, so we're going to multiply by 2 over 2 on the first part. So it's going to give us 6x plus x over 2. That's going to end up being 7x over 2. Really not a difficult concept when you take the exponent away from the base and just kind of do it separately and then put it back on. So when you put it back on the base, it's going to be 7x over 2. That's going to be your solution. All right, easy peasy. Fractional solutions just by taking this as an individual expression and combining it into one term, which makes life a lot more simple, makes this a lot simpler to look at, easier to see. Okay? All right, so let's look at the next problem. So again, we've got these values that we can separate through the operation. So I'm going to do that. I've got m to the a, m to the negative 2, p to the a, and p 1. We're just going to leave the 1 right there for the sake of, looking at it. Now we've got m a to the 3 and p 2a. Okay, so I'm going to bring these to the top and see what I can do with them. So I'm going to bring, so I've got m to the a power, and this has an a, this m has an a in it. So I'm going to go ahead and bring it up, but I'm going to change the sign. So it's m to the negative a over 3. And then I've got m to the negative 2. All right. Now I've got my p's. I've got p to the a power, and I've got p to the 2a on the bottom. I'm going to change the sign, p to the negative 2a. And then I've got p to the 1 right here. All right, so now I'm going to look at combining the ones that have this like term in them. So I've got m a minus a over 3. So I've got, and then I've got minus 2. So that's all of my m's combined. So let's combine all of our p's. A minus 2a plus 1. That's all of my a's and all of my p's combined. So now I'm going to try to find, like, this needs to find a common denominator in order to be solved. So I'm going to bring this to the side. A over 1. The common denominator is going to be 3, so times 3 over 3. And that's going to be minus a over 3 minus 2 over 1, common denominator of 3. All right, so that's going to be what I'm looking to do. So that's going to make it 3a minus a minus 6 all over 3. So 3a minus a, that's going to be 2a minus 6 over 3. So m is to the 2a minus 6 over 3 power. So let's do the same thing here for p. We don't have a denominator. Everything is a whole number. So we can just go ahead and perform this calculation. We've got 1a minus 2a, so it's going to be a negative 1a. So it's going to be p with a negative a plus 1. Well, we know we don't like to write more symbols than we have to. So we're going to rearrange that. So we've got m to the 2a minus 6 over 3, p 1 minus a. There is only one more thing that we can do to further reduce this entire thing, and that is divide 6 by 3. basically bring this back to the -2. So we have m 2a over 3 minus 2. That is the most reduced that we can do to the entire thing. So the exponent for m is going to be 2a over 3 minus 2, and the exponent for p is going to be 1 minus a. Next problem. Okay, so we've got a to the x to the m, so that's going to be a xm, and then we've got bx to the m plus 3. So it's going to be bxm plus b hang on, there doesn't need to be a b there, plus 3x. So bxm plus 3x. And then in the numerator, we have a to the negative m. Well, we need to bring that to the top and make that a to the positive m. Right? Okay, so I've got an a and an a. That means we can combine them. So it's going to be a to the xm plus m. All right, so then we have b xm plus 3x. And I think we put these in alphabetical order as well. Let me double check. Yes, we put these in alphabetical order as well. So you've got a to the mx plus m, b to the mx plus 3x. And I do believe that's your final answer. Yes, this is the final answer right there. All right, let's see. I think there's another problem. Okay, here's the next one. All right, so we've got, it's sometimes easier to just sort them out. So when they're so close, sometimes it's hard to tell what you got. So we've got y to the b, x to the c plus 2, y to the b over 3, and then we have x negative 2 minus p. All right, those are our 4 terms. We've got 1, 2, 3, 4 bases. So let's look at putting our bases together. In alphabetical order, that'd be x and then y. So x, c plus 2, x negative 2 minus p. We know we can combine all those together. So that's going to be x c plus 2 minus p. So these 2's cancel each other out. So what we have left is going to be x c minus p. All right, so that's the x's. We've taken care of that. We move that to the side. So now let's do the y's. I've got y to the b power and y to the b over 3. So all I really need to do is multiply this by 3 over 3 to get a common denominator here. So that's going to give me y 3b over 3 plus b over 3, which is going to equal y 3b plus 1b, that's 4b over the common denominator 3. So this is going to be your final answer right here. X c minus p, y to the 4b over 3. And that was our final problem. If you have any other questions, please feel free to ask.